Welcome back to the Snowflake Masterclass. Today we are diving into Snowflake Architecture, the foundation that makes it a next generation and cloud data platform. So, Snowflake Architecture is built on three key layers, each designed to deliver unmatched performance, flexibility, and scalability. So, we will start from the first layer, and first layer is storage layer. So what's exactly the storage layer? So this layer stores your data, means it's like real the data storage action, means by name it is showing that it is storing the data. So this layer store your data in optimized way, compressed and in columnar format. These all you have to learn for the certification exams actually. So what this layer is doing, it's storing the data in these three formats, and all these three formats, which are these three formats? It's in optimized way, secondly compressed, and next one is in columnar format. There's a format of compression, you could say, and it will all happen in cloud storages. Means what I'm saying, that Snowflake architecture is saving this in this way and in cloud storage. What are these cloud storage? That could be AWS, GCP, or Azure. So that's all about storage layer. And when it comes to the second layer, next layer is query processing layer or compute layer. It is also called compute layer 2. So here Snowflake uses different virtual warehouses as shown in this slide, that there are different or independent warehouses, virtual warehouses, which exactly executing the queries you are writing. Means execution of queries will happen here, SQL queries with parallel processing. Means for example, if you are writing three different queries, so what this layer will do, if there are three queries A, B and C, so what it's doing, it's separating these queries on the basis of different virtual houses, and there are different sizes for them also. So what's the good in this Snowflake architecture is that all these operate separately. Means separation will be different for different warehouses. Obviously there will be different, these will process in different warehouses. So first thing is they will operate separately, means separate operation will be, or execution will be there. So what you can do, you can scale the compute power also. Means for example, in the same user, in the same account, there are three different users. For example, one is a data analyst, one is data engineer, and next is, for example, machine learning engineer. So I'm just explaining them. So in this case, data engineer will do ETL or ELT process, so he need the least processing power, or initially he need more. Later data analyst will need a little bit, but machine learning will need more compute power. So we can divide because of these different virtual warehouses. Means we can create the warehouses what we need on the basis of our needs. So finally there is a cloud services, and what is actually do, it handles the authentication. Means which user will access the which warehouses, which database. Means it's like it handles the user authentication, infrastructure management, metadata, query parsing, optimization, access control and security. Means all the security like things and administrator level things will be handled by the cloud services. What I said, authentication, authentication, security, access control, means who's going to access which database or which warehouse, and query optimization will be handled by this query optimization or query parsing also, and infrastructure management. So what are actually these? We are going to repeat it once more, that cloud services, for example, initially we have learned what is storage. So it is hybrid columnar storage saved in different blobs. So what I said, that it store in 3 different ways. I'm repeating: optimization will be here, compression will be here, and columnar format will be here. And it is using different cloud storages, means it's happening on the cloud storages but managed by Snowflake architecture. So it's why it is different from the other traditional databases. So next thing comes is query processing. It is like the muscle system, means massive parallel processing happens here. I told you about this, that what it's doing, it's actually doing the muscle part of the system. So what was the muscle part? It was computation, it was operation, separate operations, and it was like clustering happens here. And it's the muscle system, means the main, means work done is completed here in these sections. If you are a science student, you could understand this. Later there is administration part, and that is brain of the system. So what cloud storage is doing, it managing the infrastructures, means it is deciding that who will work on which virtual warehouse and how the data will be shared to the users, the metadata of the data available, optimizing of the queries and parsing of the queries, and security. So that's all about the architecture. So we will understand a little bit about virtual warehouses size. Now think of a virtual warehouse as a Snowflake compute engine, a dynamic cluster of servers that provide the processing power needed to run queries, perform data loading, and execute other operations. Means what is virtual warehouse? It's like a compute engine, and what it is doing, it actually providing the processing power, providing the power for what? To run queries, loading data, unloading data, and all these processes. It's likely a fully equipped kitchen where all your data meals are prepared. You can turn it on when you need it and suspend it when you don't. So you only have to pay what you use. What I said, you only have to pay what you use. So that's why the Snowflake is in trending, and it's helpful for most of the businesses. So what does a virtual house include? Means if it's in your mind that what exactly the virtual warehouse is. So each warehouse has CPU cores, means it's having different CPUs, memory, and temporary storage. Why I'm mentioning here temporary storage? Because for processing there will be a need of storage also. So Snowflake manages these resources behind the scenes on the cloud infrastructure you choose. For example, initially we have chosen AWS. So in our case, all these things are going to happen on AWS storage. So when you run a query or perform data manipulation, the virtual warehouse allocate these resources in a massively parallel way, speeding up your task. So it's actually happening on our cloud storage, but who's doing this? Means temporarily it is being saved there. So it is done by the virtual warehouses. So in Snowflake architecture, virtual warehouses are divided into different sizes, as we are wearing the different cloth of different sizes. So it's also the similar to our t-shirt sizes, from extra small x small to 6x large, as we have mentioned here 4xl. So what are these divisions? There is an access. Here we will get a, for example, let's understand it by a CPU with a small core. So one CPU with a single node, it's like a CPU containing, I'm just repeating it again. So extra small is having one node, and in this node there are approximate 8 virtual CPUs. Then there is small warehouse. There are 2 nodes, means there will be 16 virtual CPUs. Then there comes the medium, which have 4 nodes, and 4 nodes means multiplying this we will have 32 CPUs, virtual CPUs. Similarly, there will be 8 nodes with 64 virtual CPUs, and then Excel there will be 16, and similarly 4x in 4xl there will be 128 nodes will be there. So accordingly you could multiply 128 into 8 and there will be total CPUs. So each size determine how many Snowflake credits you consume per hour. Bigger the warehouse, more will be the charges per hour. So what I have written, these are the nodes. So one node means 8 virtual CPUs. So one node means it is consuming 1 credit per hour. In small there are 2 credits, so there will be 2 credit per hour. Similarly, there are 4 nodes, means 4 credit per hour, and similarly 8, 16 and 128. To save our cost, you can configure your warehouses to auto suspend. Means if you are worrying about that, I have started my that Snowflake trial, and I have put a virtual warehouse division having 1 credit per hour, means it's going to work only for 400 hours. No, it will auto suspend when you are not using it. We are going to set it also. So there are different options like auto suspend or auto resume here. So a question should arise in your mind that why warehouses sizes matters. So choosing the right size of the warehouse depend on your workload or your need. For example, smaller warehouses are cost effective for simple or low volume queries. Similarly, large warehouses are perfect for complex analytics or heavy data processing. You can resize on the fly to match your current needs with downtime or disruption. So at the end, I want to say that your virtual warehouse is the heart of Snowflake's compute power. It's elastic, scalable, and on demand. You can control how much processing power you need and only pay for what you use. If you have learned something new about virtual warehouse, so just smash that like button, and don't forget to subscribe and comment if you want me to cover how to create and manage warehouses with SQL next. Thanks for watching. See you in the next episode where we will dive into our clustering, multi-clustering, what is called clustering and all. So thank you so much, and don't forget to subscribe my channel and like and share. Thank you.